So this one's the exact opposite of the other one. So the first thing we're going to do is we're going to do the top-bottom thing. Figure out what the actual g-force of the ride is, and then we'll turn it into meters per second squared. Then we'll figure out, in this case, the period of the ride. Okay, so let's take a look at this. Okay, so at the top, 1g minus the ride is negative 0.310. Okay, so the ride has to be 1.31 Gs, right? Because 1 minus 1.31 would be negative 0.31, right? Does that make sense? Really, the maths we're doing there is just we're gonna add the ride and 0.31 to both sides, right? So 1G plus 1.31 equals, or 0.31, sorry, equals the ride. Right? So it's 1.31, that's the ride. Okay, so let's see, we've got the ride, right? We've got the g-force of the ride. It don't really give a hoot about the bottom, so now let's figure this out. So the ride, the meters per second squared is going to be 1.31 times 9.8. That'll give us meters per second squared. So 1.31 times, that's 12.838. And now they want to know the period, right? That's the confusing formula, right? So centripetal acceleration is 4 pi squared r over t squared. So 12.838 equals 4 pi squared, what's our radius? 4.8 divided by t squared. Well, my next step is going to be this, 4 pi squared times 4.8 over 12.838. That's t squared, and I'm going to calculate this whole side. I'll square root both sides. So let's see. Square root of 4 pi squared. You could have pulled the 4 pi squared outside, but that's all right. Times 4.8 outside of the radical, divided by that 12.838. I think the t is equal to 3.84 seconds. All right.